Hello everyone, how's everybody doing? I hope you're doing fine. And hopefully today we have a fine day, a fine physics and philosophy day. What do we have today? Well, uh, what do we have today? We have a couple things. The first one I'd like to start, someone made a comment relating to the electric universe. Electric universe is a dissident group that does not accept the explanations of the mainstream. Specifically, they don't accept the cosmic version of the establishment of mathematical physics. They don't accept warp space, and they don't accept black holes, dark matter, all that kind of stuff. Uh, on the other hand, they do accept quantum mechanics. And they might say, no, no, Bill, you're wrong. We don't accept quantum mechanics. They accept the most important part of quantum mechanics, which is the quantum atom. And that's where the problem starts, okay? They do everything with the quantum atom. What is the quantum atom? It's the planetary atom. Niels Bohr, and um, Ernst Rutherford's, circling electron bead. And with that, they intend or they pretend to construct a continuous universe, filaments, electricity, and so on. Okay. Okay. So, what was the comment? Here's the comment that this fellow made. Okay. He came over to one of my videos and put this comment. And it says, Bill is not only using an outdated unit, Tor. He wasn't familiar with the Tor, I guess, here. He is also cheating his viewers. Aha. The density of gas in plasma clouds, plasma, you put, okay, in the interstellar medium is between 10 to the, well, he put minus, or I guess he meant 10 to the fourth, and 10 to the fifth particles per centimeter cubed, which would be between 10,000 and 100,000. Okay? And the cores of giant molecular clouds can be more dense. Okay? So, where did I cheat my viewers if I said the same thing, essentially? But he's got something wrong there. And what's wrong is that he said interstellar. We have no idea what vacuum levels we have interstellarly or intergalactically. Okay? These are estimates, calculations, they are projections. That's all they are. Those values there apply to the solar system. That's where we measured the vacuum. Okay? And those numbers are not very precise either. We use like ion gauges to measure vacuum, and they look at how many blips the ion gauge detects, and that's it. And they estimate, how much, uh, how many particles there could be per centimeter cube, based on that. So those are general numbers. The best way to look at vacuum really is, again, through a scale in torrs, in millibars, or pascals, or whatever. Okay, we don't know how many particles are per each one of these values. And he continues, he says, every explanation without predictions and tests, experiments, right? And any opportunity to potentially falsify the explanation, the theory, okay, is non-scientific, silly stammering without any use value. And it's interesting that he would say that because, he's denying the experiments. I mean, not that experiment has anything to do with science. Experiment, like he's got a weird notion. He's got this old-fashioned notion of what science is or ain't. And we have a new new version of science. There's a paradigm shift, and we have a new version of the scientific method, and we have new use for experiments in science. Experiments is to show, or tests are to show to oneself, to verify one's theory, and all that does is just enhance the belief that one has. Evidence is only useful for belief. It has nothing to do with explanation, with the objective explanation of how something works mechanically. And this fellow's not there yet. He's got a long ways to go still. But anyways, the deal here is that he says 10 to the fourth to 10 to the fifth particles, which is about 10,000 to 100,000 particles per centimeter cube, which is what I said, which is the number that's quoted out there. So what was his point? I don't know, because all these people, they come in there, they put comments, but they don't make a point. What's the point? What is he trying to say? Is he saying that I said something different, that I said that I'm trying to mislead you, saying that there's not that many particles? No, I said exactly the same thing. I said there are so many particles per centimeter cube, and I based that number based on only what the mainstream has shown out there. The astronauts go out there, they put a device that measures the vacuum, and they come back and they say, this is the number we think of particles that we think that are per centimeter cube. And I just took that number, and that's the same number he put in there. So what was his point? Okay, so I don't know how I'm misleading just by quoting the same number he quoted. But let's continue. Here we have an answer to that a little bit, so that we put it in the right context. Approximately 10 to the minus 11 torr. These are different sites that put these things up there. There are still plenty of molecules in the gas phase, about 300,000 per centimeter cube, which is about right. Atmospheric pressure, 10 to the 19th molecules per centimeter cube. That's room pressure or vacuum, right? That's the pressure that you get at room normal. That's your normal pressure here on Earth at sea level. And the moon, you got 80,000 total atoms per centimeter cube, which is about, again, it's the number that's kicked around, okay? For about 2/3 of each orbit, the moon is outside the Earth's magnetic field. All these times, a typical proton density is 10 to 20 per centimeter cube. That's Apollo 14. So they have apparently a different number. So, I quote those numbers just like anybody else. We don't know. We don't know. Nobody knows how many particles exactly. Nobody's gone in and counted each one. No such thing. It's a general calculation based on how many blips they get on the detector. Okay. But what's the issue? When we went to the moon, and this is just out of Apollo 14, but there were a couple others, Apollo 15 and 17 also measured the vacuum on the moon, or the pressure on the moon, right? And the number they came up with is about 10 to the minus 12 torr. Okay, whatever that number means to you. Okay, it doesn't. I'm just going to make a comparison here, so that number doesn't have to mean anything specific to you. The solar wind is even. There's more vacuum. There's less pressure. Right? It's 10 to the minus 13th torr. Okay, those are the numbers that these folks have measured out there. Okay, so what's the issue? The issue, if you go and look up, they test the astronauts before they go out into space, like to the moon, or even into the solar system, like orbiting the Earth or whatever. They put these guys, these astronauts, they put them in a chamber that's in Ohio, okay? And that chamber is pumped down to what it shows here on the Wikipedia, which is a 10 to the minus 6 torr, okay? You see it there? Okay, so that's what the facility runs at, 10 to the minus 6 torr. And the question is, why did they choose that value? Okay, why? I mean, if the moon is at 10 to the minus 11, why would they test anyone at 10 to the minus 6? You would think that they should test them at 10 to the minus 11 before sending them out there, which is a higher vacuum, right? And one issue is economics. It takes a lot of effort to pump down to 10 to the minus 11. Okay, that's one issue. The second one is not needed. Okay, it's not needed because anything above 10 to the minus 6 for the purposes of training astronaut or submitting them to that kind of environment makes no difference. And the third, one of the reasons, is that at 10 to the minus 6, you don't get any electricity. And this is what this fellow doesn't understand. What he insinuated was wrong when I said that, I'm misleading you. No, there is no electricity at 10 to the minus 6. That's the reason they set that number. See, they could have done it at 10 to the minus 3, 10 to the minus 4, 10 to the minus 5, but they're up to 10 to the minus 5 torr. You can still get some arcing. Arcing is a zap. It's a bolt. Zeus sends his thunderbolt, one time only, electric shock, that sort of thing. And you might get still some arcing, but at 10 to the minus 6, there is no arcing. Essentially, there is no electricity there. And out there in outer space, on the moon, right, where everyone except the flat earthers believes we've gone to, at least, right? Out on the moon, there is no electricity, and which is what the electric universe believes gravity is. The electric universe, I covered it a couple of weeks ago. Electric universe thinks that gravity is really electricity. There's electricity flowing from the earth to the sun, or the sun to the earth to the moon, and so on. We're full of electricity everywhere. Well, and this guy talks about, running experiments and believing in experiments. Well, it turns out we run the experiment. We sent the astronauts constantly out there in outer space. Some of them do spacewalks outside the capsule. Others landed on the moon. They were there for several hours. And none of them got zapped. As far as I know, there's been no electrical accident out there in space. And you would think that, electricity has to flow constantly if gravity is electricity, right? There should be electricity constantly flowing between the Earth and the Moon, between the Sun and the Earth, between the Sun and the Moon, between the Sun and Jupiter, between the Sun and Pluto. Should all be electric. We're talking about a plasma universe, plasma ball solar system here. So there should be electricity flowing constantly. It's even worse than plasma ball, because the plasma ball, as I explained a couple of weeks ago, only gives a zap here and there. It's intermittent. Gravity's not like that. Gravity's not intermittent. It's not like you sometimes jump and stay in the air, and sometimes you jump and come back down. No, whenever you jump, you always come back down, because gravity acts on you constantly. Whatever gravity is, it acts on you constantly. And so electricity cannot be like a plasma ball. It's got to be more constant than a plasma ball. It can't be just zaps against the edges of the glass there, right? It's got to be like when you run a circuit. It's got to be continuous. And these guys go to the moon, and none of them were zapped ever so far. And some do spacewalks. None of those guys were ever zapped. You would think if electricity is flowing through that solar system, not only to the moon, to the earth, but to Pluto, to Jupiter, to the other stars, because our star is connected to all the other stars in every direction, three-dimensionally, radially. You would think that these poor guys would be, trying to avoid, being hit by the rays, by the electricity, whatever electricity is. So they have gravity because, the astronaut is attracted to the Earth when he does his spacewalk. He's attracted to the moon. He can jump a little better than here on Earth on the moon, but he doesn't fly out into space because the moon pulls him back down. So if gravity is electricity, he's got electricity going between him and the moon, right? If we're going to go with their logic. Well, if electricity is running constantly, right, that means he's being zapped constantly. And again, if electricity is flowing throughout the solar system, he should be zapped. No astronaut should survive. And the alternative is to go with a flat Earth society and say, they never went to the moon or into space, right? So yeah, we got a problem there. And so just continuing with that, here's the vacuum levels, right, that I showed some time back. And you can see the moon is about 80,000 particles or molecules per centimeter cube. Again, an estimate. But you can see the different levels. Like here on Earth, we usually, like in a production facility, like in a semiconductor processing where I worked, you run it in the level of 10 to the minus 7 torr. And you can't run a current at 10 to the minus 7. And what happened is that, you run it, you pump it down to 10 to the minus 7 torr, and then you immediately have to fill the vacuum chamber with an inert gas such as argon, which is what you're going to be using as bullets to hit against the target. So you can run a current at 10 to the minus 3. You can't run a current at 10 to the minus 7. You might get some very occasional arcing, but not a constant current. And at 10 to the minus 11, like on the moon, you can't run a current at all. You won't see a current at 10 to the minus 11 torr. And for sure you won't find it in interstellar space, which is what this fellow is talking about, which is calculated to be at 10 to the minus 16 torr. There's simply just not enough density of matter to run a current. You don't have enough atoms there to run a current. And you might say, well, where's the catch? Why are these people so misled, the people from the electric universe, who believe in this notion that the electricity runs the universe rather than gravity? Or if you want to look at it a different way, that gravity is actually electricity. Okay? Well, this is the world that they see. Okay, they see something like this, and they see, oh, look at all those filaments. That's electricity, right? And that picture on the left doesn't look like the picture on the right, the motion one. Here you have a lightning bolt, right? And they think that the one on the left is more or less like the one on the right, but that can't be true, because you can see that the one on the left, it doesn't change. It stays the same way constantly. Like if electricity was constantly flowing in there, it would have to be for that to be a picture that stays that way all the time. See, but it doesn't turn off like the one on the right. The one on the right, sometimes you see the lightning bolt, sometimes you don't. Then the night sky goes dark again. And that's not what you see on the left. And so the issue with the one on the left is that it's better to think of that as gases and atoms and other debris that's out there in the universe lining up along, the gravitational lines. And what are those lines? Well, now we can find out with a rope. With a rope model, we can see why they align that way. But that's got absolutely nothing to do with electricity. Even if you don't want to ponder the rope model, what you're staring at there on the left-hand side, that's not electricity. But that's what these people think it is. They say, oh, look at all those filaments. That's electricity going from one star to another. No, that ain't, because if it were electricity, it would have to be constant. And it would have to be along like a circuit, right? A circuit, it would have to be constant, and it would always be in the same pattern, which you see there. But see, they're thinking of a plasma ball universe where, they have electricity here and there, and then it turns off and then it turns back on, and gravity doesn't work that way. Okay, so this is a bad picture. In fact, this is the way they look at it here. They think of it as a plasma ball universe. Okay. And again, if what many of them don't know is a plasma ball, does not have any high vacuum. Plasma ball runs at atmospheric pressures. Okay, so there is no vacuum inside a plasma ball. And what you have is gas, and you just have electricity flowing there and creating all this fancy effect. But they have these notions that the filaments are electrical. And what's the explanation for that? Well, that comes from this fellow, Ralph Sainsbury. He's the guy who really set the electric universe in motion. And what did good old Ralph say? Well, he says, look, regarding the attraction of the planets to the sun, this requires an additional dipole inside the planet's nuclei, oriented along lines between the nuclei and the sun, roughly parallel to each other into a line from the center of the planet to the sun. This guy is saying that the atoms align. Okay, in order to create this electricity, you have to have this atom which is not perfectly circular. It's elliptical, and it's got the electron on one side and the proton on the other. So you have this electrical direction where you have positive to negative. Okay, and the way he says, well, the way the Earth is attracted to the sun is what you have the positives on the outside of the Earth's skin and the negatives on the outside of the sun's skin. And again, these people don't illustrate, don't make a movie of what they're talking about because they wouldn't be able to make a movie any way they want to explain it. But that's the first problem. A bigger problem is what I said at the beginning. What does the atom of the electric universe look like? And of course, what the electric universe folk, poor dears, what they did, they borrowed the quantum atom. They used the quantum atom. And here you see Mr. Wal Thornhill. He's the head honcho, the head guru of the electric universe. And he says in his paper, Electric Gravity in an Electric Universe, says all subatomic particles, including the electron that's at the bottom, okay, are resonant systems of orbiting smaller electric charges. He's talking about charges, whatever charges is. I guess he's talking about his Visa or his MasterCard, of opposite polarity that sum to the charge on that particle. So what kind of model does Mr. Thornhill propose? He's proposing a particle model. What is the atom? There it is. You see it. The atom, it has a proton ball in the center. You can think of it as a bowling ball. And that bowling ball is orbited by an electron bead. That's the atom that the electric universe uses. And with this, they want to explain electricity. And with that electricity, they want to explain gravity on a universal level. And so what is the problem? Well, the problem is that the first thing they have to do is tell me why the electron bead remains faithful to the proton bowling ball. That's where their whole system collapses, because no one in quantum, no one in the electric universe, no one on planet Earth using this model, this ridiculous model of the atom, which is still being used officially, can tell you how the electron bead continues to be faithful to the proton. Why doesn't the electron bead fly away, spontaneously fly away? What keeps it there? What physical entity? Don't talk to me about charge. Don't tell me it's positive. Don't tell me it's negative. Tell me what tell me the mechanism. I want to see the mechanism, what holds the electron bead tied to the proton bowling ball. Is it other particles? Ether maybe? As the etherists would say, is that what compresses or builds a shield around the atom, all this ether that surrounds the atom? Is that what prevents the electron bead from flying away? And then when you ionize it, what made the electron bead overcome that ether? Assuming that's what people propose. So the first thing that anyone who proposes this ridiculous model of the atom, the planetary atom, has to do is tell me how the electron bead remains faithful to the proton bowling ball. That's sine qua non. You got to start there. If you can't do that, you don't have a theory. We don't care about your theory, okay? Because you don't have a rational proposal to begin with, okay? And it doesn't stop there, because what happens next is, this is the model of electricity that these people have in their tiny brains, okay? And that's that, electricity is the flow of electron beads from one atom to another. That's the model they have, okay? Now, quantum has outdone them, because quantum knows that there are no such things as real particles, as corpuscles, okay? So what has quantum done? Well, they got rid of the proton and they just left the electron beads. Okay, that's the model that quantum proposes. They say electricity is just a flow of electron beads, and now they got rid of the atom, so now what you have is electron beads going from one galaxy to another through empty space. And of course they know that's not true, but that's what they insinuate, that electricity, forget about the atom, all you need is the electron, okay? And so, yeah, we got a problem because, if you compare it against the model proposed by the Rope model, it's atoms twirling in place, okay? So that's electricity. And so you do need atoms. You can't do electricity without atoms, as all these other folk propose. They think that beads are flying through empty space, and it's just a matter of giving it more force if there's more space between the beads. So if you want the mean free path to increase, all you got to do is increase the force. That's essentially their model, okay? And here you can have a comparison of the three models. You got the classical model, which is what the electric universe pretends to do electricity with. You've got the quantum model where they get rid of the proton and they just do it with electron beads, and you got the rope model, which is serpentine twirling in place, which is a bunch of atoms which have their shells covalently bonded, and the whole thing is twirling. That's electricity. So you need atoms. And the problem with that for the electric universe, if they're going to try to do gravity with electricity, is that when you have 10 to the minus 11 on the moon, or maybe 10 to the 12, minus 12, or 10 to the minus 13 torr, as in the case of the solar wind, which is supposed to be the gravity. There's not enough. There's not enough particles per centimeter cube to produce electricity. And don't take my word for it. Just go to anyone who works with vacuum chambers and ask them, can you run a current, a consistent current from cathode to anode when you pump down the chamber and put no species in there, okay? You just pump down the chamber to 10 to the minus 7, 10 to the minus 8. If they can achieve that, it's very hard to achieve. Some labs have achieved 10 to the minus 11, 12. They say the record is 10 to the minus 14. I don't know how they even measure that, but let's concede. Can you run a current at that level of vacuum? And the answer is no. And that's where the electric universe dies, because there is no electricity out there in space. Otherwise, our astronauts would be zapped. But try to explain that to an electrician of the electric universe. Anyways, today we're going to talk about something else. We're going to continue our series of Ayn Rand. And we were on the issue, especially of existence. So let me review really quickly what I covered so that we have an introduction here. And it starts out with this, what Ayn Rand thought philosophy was. Okay, and the way she looked at it, she said it's just a bunch of recommendations. And you got these notions, a guide for a living, course we take in life, how we treat other people, that sort of thing. According to Ayn Rand, it also includes ontology, metaphysics, essentially the science of existence, which we're saying that's physics. That's got nothing to do with philosophy. And she thinks it's a jack of all trades. It covers every base. What she called the soil which makes the forest possible. Before you can do any discipline, for example, if you want to do physics, if you want to do biology, if you want to do, even history, right? You need to start at philosophy, she says. In other words, this is the notion that she has and a lot of people have out there, that you start at philosophy. You have to have a brain, you have to have awareness, you have to have observation. See, touch, smell, taste, hear. And the question is whether that makes any sense, because then what is philosophy if it's everything? Okay? So we need to define this word philosophy before we can use it in a sentence if we're going to have a rational discussion, a rational debate, an exchange of ideas. Otherwise, if you're just going to introduce the word philosophy every time you just want to make a point and you never defined it, then we don't know what you're talking about. It's a worthless word then. Because of that, they developed all these irrelevant subjects and branches that have nothing to do with philosophy, which are just opinions, in other words, known as religion. And we have politics, justice, ethics, aesthetics, epistemology, which is about knowledge. And so what do we say that philosophy is in the alternative? Well, we have science is rational explanations, and philosophy is one of the two sciences, the two major branches of science, whereas physics deals with rational explanations of mechanisms. Philosophy deals with rational explanations of behaviors. Now we can use, these notions in a consistent manner. Now we know what we're talking about, okay? Why do we use that? Well, because we're trying to establish the foundations of physics. That's why we had to divide it this way. We had to redefine what science is, because no one defined science in a rational manner. No one defined physics in a rational manner, or philosophy in a rational manner. No one can use these words consistently, rationally, in a discussion, in a debate. We don't know what they're talking about when they say physics, because these people say physics is math. Physics is math, measurement, calculation. You just measure something, give me 1 meter, and that's You did physics, you did science, and so we got a problem. We got a problem because none of these words were defined. We had to establish the foundations of physics for the first time in history. So all those notions that we've had for the last 2,500 years, primarily in the last 400 years, at least since the 17th century so-called scientific revolution, right? We had to redefine what physics is because they lost their way. The reason we have all these irrational interpretations of Big Bang, of space-time, of black holes out there in space, on a cosmic level, is that we never defined physics. These people are just talking nonsense at this point. Okay, none of it makes any sense anymore. And a lot of those who are rational folk, they realize there's something is wrong, that we're not getting the information we want. We don't know how the Mother Nature runs her invisible shop, how she runs gravity, how she runs magnetism. She doesn't know. We don't know this. No, people want to understand how this universe works, and these people say that's philosophy, and the philosophers say no. Ours is the the soil on which the trees grow, etc. And what do we have? We have nothing. That's what we have. We have no understanding of how the universe works. Okay, so let me just put it up here, a comment that someone made with respect to this. Okay, it goes something like this. Many philosophers would say that, philosophers, quotations, again, we need to define philosophy to find out who is a philosopher. Okay, they haven't done that, so that word can't be used to begin with, but let's continue, would say that the distinction between science, physics, and on the one hand, and philosophy on the other, is that the former answers empirical questions, whereas philosophy answers analytic or a priori questions. For example, it's an empirical question if we can practically make machines with general artificial intelligence. That's answered by computer science. No, it's answered by technology. Again, it's people who confuse science with technology, and I like to beat them up constantly. You don't confuse technology with science. Technology we develop by trial and error. We have no use for science in technology, and we have no use for technology in science. They have nothing to do with each other. A refrigerator has nothing to do with science. And you say, well, how did we develop the refrigerator? Well, we developed it by trial and error. We did one thing, another thing, we finally got it right. Does that mean that the guy who invented the refrigerator or the TV or the computer or the cell phone, do they know what a magnetic field is? Do they know how gravity works? They don't need to. They just did something and said it worked, and now they sold it. That's technology. Okay, you develop it. That's why they go into these parts of the companies, manufacturing companies, known as research and development. It's not called science because they don't use science. They use research and development. They just try one thing after another in the lab. They test. And they have some notions already of how electricity works, how magnetism works, and they just apply it. That's it. They don't have to know what an electric current really is. They don't have to know what magnetism really is. They just need to know what it does. That's why science and technology are unrelated totally. Science has to do with understanding how Mother Nature runs her shop, especially her invisible shop. We know all the visible stuff. What we don't know is the invisible stuff. Okay, and then continues. Prior to that, though, there is the question of what intelligence really means. Well, then you define it. Again, nothing to do with philosophy. Definitions are not what is it? They don't belong specifically to philosophy. Quite the opposite. They belong at a higher level. They belong to science. Science is the one that the scientific method. Maybe I should put that up there so that we can see what I'm talking about here. Here's the rational scientific method. Okay, and now you can see where definitions belong. They belong in the first step of the scientific method. That precedes both physics and philosophy. Definitions don't belong to philosophy. They belong to the rational scientific method. If you're going to explain your theory to someone, you better start with definitions. That's not an issue of philosophy. That's an issue that pertains at the more basic or fundamental level, which is at science. First, you have to know what science means, okay? And if philosophy is a branch of science, it must follow the rational scientific method. Um, so, anyways, the issue that philosophy underlies all of science, that's nonsense. It's not philosophy. That's the rational scientific method, or call it the scientific method, that you have to put in before you do science. That's got nothing to do with philosophy. That if philosophy is an opinion, or whatever philosophy means to you, you got to define the term before you can use the term philosophy. And again, it's right now people have no idea what the word philosophy means. That's why we had to define it. And philosophy only deals with behaviors, explaining a behavior. That's philosophy. But to say that philosophy is everything, existence and justice and ethics and also aesthetics, that's nonsense. That's no definition at all. We can't use that in any old way. Okay. Well, anyways, Ayn Rand also, some call her Ayn Rand, also, just to review, she called her so-called philosophy, she called it objectivism. Okay, and what's the problem with that? Well, it relates consciousness to existence. And as soon as you introduce consciousness, you're way far away from what is known as objective. And it includes irrelevant features like happiness, productivity, morality. All those things are opinions. That belongs to religion, not to science, not to philosophy, if philosophy is a science. Which Ayn Rand, by the way, as you saw in the previous, here it is again, she called it, science. Was that it? No, got the wrong one. I think I'll get to it a little later. Anyways, the point is that according to Ayn Rand, philosophy was one of the sciences. Okay, here it is, I think. Let's see. Somewhere she said it's a science. Yeah, there it is. The second one includes ontology, metaphysics. Philosophy is the science that studies existence. So Ayn Rand believed that philosophy is some kind of science. So she had it backwards. She said you start with philosophy, you end with science, but philosophy is one of the sciences. And again, she didn't define science either, so it didn't matter anyways. Okay, so what's my objection to it? Well, if you look at the word objective, like if you look at the Wikipedia, and it says being the object of perception or thought, belonging, I don't think it was the wiki, I think it's just the dictionary, but belong to the object of thought rather than to the thinking subject. Okay, not influenced by personal feelings or opinions. I pretty much agree with all that. And subjective, existing in the mind, belonging to the thinking subject rather than to the object of thought, etc., etc. And that's the notion that I have also in general terms of what objectivity and what subjectivity mean. Objective means that, you kill the observer, get rid of the observer, okay? And once you get rid of the observer, then you know that what's left is objective. And it's when we introduce subjectivity like consciousness and so on that we mess it up completely. And we call it objective, but it's subjective. Because at that point, people introduce what they saw, what they felt, what they believe, and they say, well, it's objective, and I proved it. It's the truth, okay? Ayn Rand did a lousy job at defining also, rationality. If I can get it up here. There it is. Okay, and you can see the difference between what she calls rational and what I call rational or irrational. First, she uses synonyms. Reason. Reason essentially is a synonym of rational. Then she includes irrelevant features: knowledge, consciousness, awareness, choice, perception, reality, mental focus. That's the terms that she uses to define rational. What does any of that have to do with rationality? No, it's got to be objective. And here you see the criteria we use in rational science. The main one is that first one there, treating concepts as objects. When you try to move a concept, you're moving intelligence, you're moving data, you're receiving information, then you know you're talking in ordinary speech, in the vulgar language. You're not talking scientifically anymore, okay? So it's very poetic. It's very nice to say love moves mountains, but that doesn't work in physics. I'm sorry. You can't use that literally in physics. You need objects to do physics, not concepts. Okay? And then, of course, using inconsistent definitions, and there you have the rest of the list. But that gives you a general view of what the term rational or irrational in this case means objectively. Okay? So these are things that you should keep in mind when you're looking at definitions and at Ayn Rand. People don't read these things critically when they're reading Ayn Rand, so they become fanatics of Ayn Rand because she gave you an idea of how to live. She said, "Look, I think like she talked about altruism." Uh, the fact that should you save someone who's drowning, well, if it's your wife you might want to save her, or the girlfriend, and and if it's someone else, should you save that other person? Those are opinions. And she just gave you an idea of how to live, how to behave, what the best political system is. All nonsense. All of it is just opinion. We have all kinds of opinion. We have 8 billion opinions here on earth. Okay, so politics is religion, and justice is religion. There is no such thing. What is justice to one is injustice to another, and so on down the line. All those are opinions. That's why I got out of politics, by the way. Okay. I mean, who should I vote for? Should I vote for Al Capone or for what was the name, Bugs Moran? I mean, which is the better mafia? I mean, should I vote for Al or for Bugs? Those are my choices, I guess. No, get out of politics. If you ever do politics, you're doing religion. Okay. Okay, we have a difference also in the word exist. What is existence? Well, Ayn Rand had a lot of synonyms. She says reality exists, existence exists. Those are very poetic words. Love it. Word wizardry. You can use it maybe in a song. We can't use that nonsense objectively in a discussion, in a debate. Okay, she included the observer, making it completely existence based on what the observer sensed. Very subjective. Knowledge, consciousness, perception, see, touch, and the use of the senses. She said something exists which one perceives. No, absolutely not. Something exists which we define, which meets the definition of exist. That's what exists, not what we perceive. And she says sensation tells man that it exists, an entity exists. No, sensation has nothing to do with it. It's the other way around. Once you kill the sensations, all living entities in the universe, what remains behind is what exists. Okay, that's the way you should look at it. Not discover what exists through sensations. And I gave the example of a magnet around a magnetic field. A magnetic field around a magnet. Here I have a magnet. Okay, I always show that. Okay, that's a magnet. It's got a little. You can see it there. Magnet. Okay. Okay. Now your senses tell you that something is there. Okay. Now you only have one. Can you tell me, without doing any experiment, anything? Can you tell me with your senses, if a magnetic field exists in that magnet, or is it just a piece of metal? How can you tell the difference unless you put it to the test? But you cannot tell me that the magnetic field exists through the senses just by looking at a piece of metal. That's the point. Okay? And so no, the senses are useless to determine, especially Mother Nature's invisible mechanisms. And that's what Ayn Rand never figured out. Okay? That's simply a fact. So where does Ayn Rand's philosophy lead you? Well, I'll show you where it leads you. It leads you to hell. Okay? Yeah, well, I want to put it over here. Let's see. So you can see it here. Okay, the axiom that existence exists means to grasp the fact that the universe, its basic constituent elements, are atoms or subatomic particles or energy. Oh, is that what it is? So she's already proven, she's already confirmed through her senses that particles exist, that quantum is right, that you have subatomic particles, and that energy exists. What is energy? Is it a physical object? Does she require energy to be a physical object before she can talk about the existence of energy? So she has these notions of existence, but she ends up with nonsense. She says that particles exist. So she's confirmed particles. It's a done deal. I have no chance of challenging her because it's already been confirmed, right? Through the senses. And again, you got to think about what she's saying. You got to read her critically. You can't just go over and say, "Oh, I like what she said about politics." You know, we don't care about politics. Politics is religion. It's not a part of science. There's no such thing as political science. It should be called political religion. Politics is all opinion. Ethics is all opinion. Ethics belongs in church. Okay? There is no such thing as ethical. Okay, ethical is opinion, 100% opinion. Ask the lion when he kills the bull if he has any ethics, if that was unethical of him. Or ask the bull, let's see what opinion he's got, and he'll give you an idea. Okay, so Ayn Rand ends up with defining what an entity is, but as I say in the title of this video, she's going to confuse entity with existence and existence with entity. Like all the other philosophers, so-called philosophers such as Hume and Kant specifically, who dealt with the same issue, she ends up with the same conclusion, that there's no difference between entity and existence. She thinks that the word physical means existence, and it doesn't. That's ordinary speech. That's the vulgar language. In science, you can't do that. You got to distinguish between entity and existence. And here's her version. Okay, let's go with her version first, and I'll put mine next to that. Entity has to be defined ostensively, that is to say, by pointing. I love that. If she would have stopped there, she would have done a good job, or she would have been in the ballpark, because what do you point to? Can you point to a concept? Can you point to information? Can you point to intelligence? Can you point to energy? No, you can't. You're going to point to some kind of shape, something that has a perimeter, a surface, or something, right? It's got to have shape. And if she would have stopped there, it would have been okay. But she muddled it further by putting an and, by aggregating stuff that didn't belong there. And that shows that she did not understand what an entity is. She says, an entity is a this which you can point to and grasp by human perception. That's where she screwed it up. No, an entity is not that which you grasp by human perception, meaning senses first and then reasoning afterwards, right? After you touch, then you reason, you're conscious, you're aware, and you now make sense of it, right? No, it has nothing to do with the individual. An entity is that which you can point to because the entity has shape, not because you can point to it, not because you do something to it. Okay, so that's where she screwed up. She tried to cover every base, and that means she did not understand what an entity is. Okay, let's be fair here. An entity means a self-sufficient form of existence. No, not really, because an entity, if it's which you can point to, I can point to a square, and a square does not exist. I can point to Superman, and Superman does not exist. And I can point to a tri-bar, and I can point to two-dimensional figures, right? Geometries or whatever, or even, again, figures. I can point to Mickey Mouse or Bugs Bunny. And that doesn't mean that Bugs Bunny exists, okay? And so the fact that I can point and identify a shape does not mean that because of that, the shape that I'm pointing to exists. And again, you have objects that exist and objects that don't exist. You know, we have leprechauns and God, spirits, angels. You know, we have a whole host of imaginary, what are known as imaginary objects that you can't point to. I can draw them, and I can even point to the drawing, but what I'm pointing to, the object that exists, is the paper and the ink, not the figure that, I made with it. Okay? So she didn't realize that difference. Okay? And she said solid things which we can directly perceive. Again, she's equating, and that's why she gets into trouble with existence. She's equating entity with not only that which has shape, but that which is three-dimensional and which exists. And then, of course, she ends up saying, well, there's no difference between existence and an entity, or what she called an existent. You see the problem? The problem is all these people had the same problem. Every one of these so-called philosophers had the same problem because they used ordinary speech. They thought that an object is that which you can point to, and the senses tell you something about it. You can touch or see maybe, and because of that, they said, "Oh, yeah, it's got to be something three-dimensional, something you can touch." And then they said, "Oh, then there's no difference between an object that you can touch and one that exists." And so they equated entity with existence, or in this case, existent to existence. They created this existent, which is this word existent, which is a blend of object with existence. They're both the same. So they call it an existent. Okay, no such monster. And again, an entity is a solid thing open to human perception. When you put human perception and capable of independent action, well, independent action, yeah, but again, squares don't move. Okay, typically they don't move. If they do, you had too many beers to drink. Okay, but here she screwed it up completely, and you see how she had no notion whatsoever, no knowledge, no understanding of what an entity is. An entity is a thing. No kidding. Synonym. An entity is a solid thing with a definite boundary. So far, so good. But then she says, as against a fluid, which, such as air. Air is not an entity. These are her words, okay? When the wind moves as one mass, you can call it that. Fluids are not entities. So she says water is not an entity, not a thing, for the purposes of her philosophy, obviously, objectivism. And neither is air. Why? Because according to her, it doesn't have a definite surface. And I can't point to that blob, so blobs are not entities. The blob is constantly moving, or maybe it doesn't have shape to begin with, or the water takes the shape of the glass and the air takes the shape of the balloon. That's its volume, right? So because of that, air itself is not a thing, and neither is water. So it turns out that you can point to a square, you can point to water, but they're not entities. So what sense does it make with her initial statement there that an entity is that which you can point to? She's got contradictions because she did not understand what an entity is. And again, I keep saying the definition of the word object destroys all religion, and it destroys Ayn Rand's religion, which was just politics and ethics and stuff that has nothing to do with anything. Okay, so what is an entity in rational science? Well, you have there that first you kill the senses, and yeah, an entity, tribar is an entity. It's a thing because it has shape, but it's an inexistent entity in the case of the tribar. So is Superman, so is Snow White, and so on. And air we cannot see. Fortunately, because if we could see the air, we wouldn't be able to see the wall. So thank God that Mother Nature, made air invisible, because otherwise we'd be in a lot of trouble. Yeah, air is a physical object. I know that sounds terrible in your ears, and that only sounds terrible because you're used to thinking of things as that which you can touch or see. But air is a thing, and so is water. They're made out of atoms, so they had better be objects. Okay, anything made out of atoms for sure belongs in the list of objects. And so not every object can be seen, and not every object can be touched. People don't understand that. They have a trouble with that because we're used to thinking of see, touch as the criteria for objects. Okay, and so what is an entity? Well, here it is. Here you have an entity. Okay, any blob, anything that has shape is a thing. It's an entity, whatever that is. You don't care. It has shape, and it has to have shape all on its own without your eyes. You should be dead, and that still should be an entity. It should still have shape, irrespective of whether you're alive or not. Okay? So it doesn't depend on our consciousness, which is what Ayn Rand essentially was saying, because she was trying to set the foundations for her philosophy, her political recommendations of how we should live in society, how should we behave. And so she tailored her definitions for that purpose. And that's why she screwed up. She started from the end and worked herself backwards rather than starting at putting the objective foundations first and then working from there to her philosophy. And she didn't care about that because she was trying to get her message of how to live and, what should be the ideal political system. She was like Plato and all these other people who just talked about, what they thought was the correct form to govern people. Okay, that's what they were into. Okay, here was another comment. A fellow came over and he says, making fun of me, he says, "What is shape, Bill G? Don't ask, don't tell." Yeah, you shouldn't ask or you shouldn't ask that question. You shouldn't ask what is shape. The definition of an object is that which has shape. And the guy immediately goes in there and says, "Well, what do you mean by shape?" And then when you give him the definition, what do you meant by that? And what did you mean by X? And well, it's because of Y. And what do you mean by Y? Well, it's this Z. And what do you mean by Z? And it never ends. And they say, see, I got you. You can't define your terms. That's their reasoning, okay? So how do we handle that in rational science? Well, what we do is we do this, and that's how we neutralize these devil's advocates, okay? We have to find an objective criteria for the word object. We have to know what an object is for the purposes of physics, because we cannot do physics without an object, period. And so all you have to know, all you have to understand is that the word see, the verb see, is not the same as the word shape. And that the word touch is not the same thing as the word see. And that motion is not the same as volume. And that color is not the same thing as 3D. Can you tell the differences between any of those words? So we have to choose one criterion, maybe a couple, I don't know, for physics. How are we going to define the word object? Because we can't do physics without an object. So we must define the word object no matter what. There's 8 billion people in this conference room. No one can leave. The doors are locked until we define the word object. Which criterion are you going to choose? That's the question. And can you defend it? It's not a question of belief. It's a question of getting inside the ring and defending your definition. All we need to know is which of these criteria we're going to use. That's the issue. And so we do not need to define shape, because all we need to know is the difference between shape and touch, or between see and volume, or mass or motion. And this is the issue. The issue, we don't have to go and please the devil's advocate and say, oh, define this and define that and define the other one. No, we don't need to. We just need to define the word object because we need the word object. And all we need to do is choose a criterion. That's how simple it is. And that's why these people always got into this endless iteration on, well, what about this and what about that? And they finally left the conference room because they had to go and eat or go to the water cooler or whatever. And they just left it hanging there and said, well, let the next generation deal with that. And today we don't have a definition of the word object, which, as I always claim, is destroys all religions. Once you define object, all religions die. You have to tell me whether space-time is an object or a concept. You have to tell me whether God is a physical object or an abstract concept. What is God? Is God love and intelligence, or is God that human magician that made the universe? Which one is he? So now you got to tell me. See, if you're going to talk sensibly, if you're going to tell me your theory, right? And this fellow also came back and said the following. He says, Bill G, again making fun of me, an object must have location in order to exist. Yeah, correct. And audience, how can you have location without a reference point, another object? Bill, you can't. Without a companion object, an object ceases to exist. Well, that's putting words in my mouth. That's not correct. That's not what I say. Okay? An object does not cease to exist. It never existed to begin with. An object exists only if it has location. So the question is, does a single object in the universe have location? And the answer is no. So by definition, pursuant to the definition of exist, a single object in the universe cannot exist, by definition. When you say it does exist, or that's your definition, then you're using the definition of ordinary speech. You have just introduced, without even knowing, unwittingly, you've introduced the notion of ordinary speech, that an object is three-dimensional, sitting there, it exists. Why? Because I can see it. Why? Because I'm the second object and there's distance between the object and me. No, if we kill all observers in the universe, That object does not exist because in order for that object to exist, it must have location. And any other notion of exist is introducing the notion of ordinary speech, the vulgar. And that's what this fellow is doing. He thinks that it exists anyways, or it ceases to exist because it has no location. And what does he mean by cease to exist? He's thinking of the notion of ordinary speech, of this vague notion that people bring in that saying, well, an object exists if I can see it, if it's there. Well, yeah, what if there's only a single object in the universe? That's all that God created. Like, for example, God himself. Here's God in the universe. Does he exist? Well, if we're going to talk about God as a whole, and he has no other object in the entire universe, well, then God does not exist. If God wants to exist, he better create another object. He's got to have location. There's got to be a distance between God's chest and mind for God to exist. And these people don't understand that. They believe that they can introduce the notion of ordinary speech in the middle of a conversation like he does here. He's saying an object ceases to exist because it has no location. By definition, it doesn't exist to begin with, so it doesn't cease to exist. And second, by definition, it's got to have location. And for that, you require a second object. So only objects that have location can exist. Yeah, and so, again, it's the circular notion that people bring into the discussion when they don't understand that you cannot bring the notion of ordinary speech, because what you got to ask this fellow is, please define the word exist. What does the word exist mean in the alternative? And give me a crisp scientific definition. Don't give me your vague notion. It's a reality. Yeah, that's a synonym. And that's what you'll find in the dictionaries. Okay, and here was another comment. Last one, I guess, for lack of time. So let's go with this one. And this fellow says the following. He says, there's no categorical difference between supernatural theories, magical explanations, and physical theories. They both posit objects and explain how they work. Okay, for example, there's an old tale that 3 foot tall elves exist in the forest. And every winter they come out, I guess, and eat whatever porridge that humans put out for them. Okay, that seems like a completely irrational physical theory. Yeah, it is. So far, so good. I don't see any problem so far. I don't know where he thinks that this is supernatural or irrational, right? By putting supernatural theories in the category of religion, it seems you perhaps want to divorce science from pseudoscience. But how do you do that without appealing to truth, belief, and knowledge? Okay, that's the question. Let's see how we answer that. Let me get it here. First, we have to find out what an elf is and what supernatural means according, to the official version, right? And here it is. This comes out of the Wikipedia. Again, more or less all the other definitions are along the same line. An elf is a type of human-shaped supernatural being. Okay, what does supernatural mean? A concept of the supernatural encompasses anything that is inexplicable by scientific understanding of the laws of nature, but nevertheless argued by believers to exist. Well, we have the problem of the word exist and the word that scientific, what the science mean, etc. So we got a lot of problems there because we would have to define what do you mean by scientific understanding, what do you mean by exist, and so on. Examples include immaterial beings, no such monster. What do you mean immaterial beings? Non-physical entity, that's what, when you look up immaterial beings, that's what it references. Non-physical entity. What's a non-physical entity when all entities are physical? So what do you mean a non-physical entity? And again, you can see this goes on and on and on because all these words are undefined. You cannot use these notions, these vague notions that we have in ordinary speech. That's the first. It's a question of language. It all comes down to a question of language. And here, just to end it, I'll show you some elves. Okay, and they do exist, as you can see here. Okay. This was Tom Thumb. He was known as General Tom Thumb in the 19th century. He belonged to the circus, to the Barnum and Bailey circus. And he's getting married there with another little lady. Her name was Lavinia Warren. And they had, as you can see, the people they brought to for the marriage was another elf, you could call them. They were 3 feet tall, as you can see there. You can see their size. Commodore Nutt and Minnie Warren. Okay, and then turns out Tom Thumb died, and Lavinia Warren remarried. She married Count Primo Magri, a guy from Italy, and that's his brother there next to him. So you can see elves do exist. And are they supernatural? No, these guys really exist in real life, and they're 3 feet tall, just like this guy said. So yeah, again, we have to define what do you mean when you say elf? What do you mean what you say when you say supernatural? And I did define that. Supernatural is an object which is imaginable. Irrational, on the other hand, what mathematical physics does is totally different. They're taking a concept such as energy or mass and saying they're going to move it, they're going to transfer it. They're going to stretch a field. They're going to bend time. Now that's irrational. That's not supernatural. Supernatural is bringing an object that you can imagine, but then you have them do some magic, something that you cannot explain mechanically. That's not what mathematical physics does. Mathematical physics goes way beyond that and says, look, you cannot even imagine this. Oh, no, why? Why can't I see energy? Why can I not touch mass? Well, because they're concepts, that's why. And these people are turning these concepts into objects and then begin to move them around. And that's the physical interpretation they give you for natural phenomena. So yeah, we have to define these terms. Anyways, we continue along this line. We still haven't finished completely, I think, with existence and Ayn Rand. And again, I pick on Ayn Rand only because she dealt with these subjects in the modern world. She essentially represents all so-called philosophers, which we're arguing here, we're not philosophers. We have a new definition for philosophy, and we have a new language. And until you understand that language, you won't understand the arguments, the criticism that are raised here in this channel. Okay, with that, I'll see you, when is it? On Sunday? I'll see you again, same time, same station. Bye-bye.